For all you tiny house, micro house, and yurt dwellers out there who might be looking for an affordable small air conditioning system, I'm going to show you how to make a packaged unit out of a window unit. Now why, you might ask, would you want to do that? Well, first of all, it's $549 to buy a small packaged unit in the range that you would need for a small, tiny, or micro house. And at Walmart, you can get a unit for $119 that will provide the same amount of cooling. But of course, it's noisy, it rattles, it doesn't have a good thermostat. And so yeah, let's get the cover off this thing and get started. Look your unit over thoroughly and remove every single screw that is either in the case or the face of the unit. Once all the screws are loose, the cover should easily tip back and be removable. The Terlingua Aircrete Workshop, October 12th through the 25th, has become the Terlingua Alternative Building School. Why building school? Because at this workshop you're going to learn everything you need to know to build this little 16-foot cabin from the ground to ready to move into in 14 days, the Rapid Cast Workshop. But not just any workshop, you're going to get to learn how to build every aspect of this, including building from scratch your own solar system, sizing and installing heating and cooling systems. That's right, from the foundation all the way through hanging the cabinets, putting the flooring in, and making it a livable structure in just 14 days. Click the link below in the description to find out more. Now, this is a capacitor, and it can hold voltage even after the power has been disconnected. So never put your fingers in there, right, Gabby? Window unit air conditioner. Alright, so what I want to show here is you have a switch and you have your cord coming in. Your black wire goes into the switch and it sends power out to one of 3 fan speeds, but only one at a time. If you hook up more than one, it'll burn the motor out. And then there's the thermostat. That wire comes down, it's a brown wire in this case, so that's what turns on the compressor. Go ahead and remove the screws holding the switches in, and then pull the switches and the thermostat out. The goal here is to make this remotely operated. Now let's remove all of the wires from the switch and the thermostats. You may have to use a little screwdriver to depress the tab to release the electrical connection from the spade. Now we're going to take the hot wire that comes off of the cord and we're going to connect them to the fan speeds one at a time. The purpose is to determine exactly which wire is the high speed. Be certain that none of the other wires are touching one another or the metal. Then plug in the unit and listen to the fan speed. And we just kind of feel the air and listen to the sound. Now we'll hook the black wire to the yellow wire. Making sure again that neither of these, because these are also hot, make sure nothing's touching anything metal or one another.
Faster.
That's clearly faster. So yellow is faster than black. I'm sorry, yellow is faster than white.
Yeah. Because the black's the power.
And red is high, so this is backwards from normal air conditioning. So we know our red wire is our high-speed fan wire. And of course, if the black wire gets connected, then it turns on the compressor. We're only going to use the high-speed fan setting. So we're going to cut off the ends of these other 2 fan speed wires. And we want to cover them with tape and tape them securely so that there's no chance that they can touch one another or get into the casing of the unit, because they will be electrically hot. We will also be cutting the end off the red or high-speed fan wire, as well as the white or compressor wire. Strip both of these wires and twist them together. We want both to be energized at the same time. Now we'll stick a crimp-on female spade terminal. You can get these at almost any automotive supply store, and you will of course need a proper set of crimpers. As you see here, there's a dip on one side and a knob on the other side, and this compresses it around the wire to hold the wire securely in place. Give it a good hard squeeze. And then yank on the end of it and be certain that it doesn't come out easily. Now here we're going to install our relay. This is typically a fan relay for air conditioners. It has a 24 volt coil and it has a rating of 12 amps at 120 volts. Now we notice this one has 4 terminals, and if we look on the side we can see from the diagram that these two are connected by default or normally closed, and that the top 2 are normally open. So we're going to connect our compressor and fan wire to one of the normally open connections. The hot wire that comes directly from the cord, or black wire, will connect to the other normally open connection. When the relay is closed, it'll send power between these 2 points. We're going to need to install a 24 volt AC transformer to operate this control system. The reason we install a 24 volt transformer is to give us a low control voltage that we can safely send inside the house, and there's no danger of electric shock. So the first order of business is to examine the space that we have in the transformer and see if any of it sticks out beyond the edge of the case. We may need to rotate the transformer in a couple of different directions until we find a direction that it fits. Normally you would just simply attach and screw these to the back plate, but in this case the transformer is only going to fit in this one direction, and we don't want to put any screws through the case in the direction of the Freon lines, because they'll penetrate the lines and basically ruin the air conditioner, and then you're going to have a whole nother set of skills and tools to fix that problem. You see on the transformer label it tells you PRI, which means primary, and this one is a multi-voltage coil, so it tells us that the white wire is common and the black wire is for 120 volts. The red and orange wire are for 208 and 240 volts. So we're going to cut these wires off just like we did with the fan wires, and we're going to apply tape over the ends and secure these so that there's no way that they can touch one another or any other metallic object. Now we'll take the neutral wire, or the common wire, from our thermostat primary side, which is the high voltage side. We'll bend the tip of the wire over and we'll crimp on another female spade connector. Now we're going to plug this into the spare connection where the common wire comes in from the cord and goes to the capacitor. Stick the connection on, wiggle the side to side, and give it a push until it drops in. But again, these capacitors can hold a charge potentially, so either short them out with a blunt tool, but just for safety's sake, avoid sticking your fingers across capacitor terminals because you potentially could get a shock. Next, we're going to take the hot wire from the transformer for the 120 volt section, and we're going to twist it around the wire that comes in off of the cord, the black wire. And this again gets another spade connection crimped on. So, starting over from what we showed you earlier, plug this hot wire into the normally open contact of your relay or contactor. Now, we have two wires remaining that come out of the secondary of the transformer, in this case blue and yellow. Blue is typically used as your common wire in air conditioning systems, so we'll just stick with that whole idea. And the yellow wire will become red as it pertains to our thermostat and our thermostat wire. Alright, so taking a piece of thermostat cable, remove the outer casing and separate your wires. We're going to use blue for common so we can send power to the transformer if we want to use a transformer for powering our thermostat without having to have batteries in our digital thermostat. We're going to connect the red wire to the yellow, and the yellow wire will go to our relay to engage the coil. And of course you could use the green wire if you had a second relay. It would be possible to wire this up so that you could turn the fan on by itself. But we're not going to do that in this particular instance. So now we connect the blue thermostat wire onto one of the two, in this case the blue secondary winding of the transformer. Now we'll strip and connect the red wire of your thermostat cable to the remaining secondary transformer wire. And we'll put on a wire nut to make sure it stays secure. And now we'll crimp on a female spade connector onto the yellow wire on the thermostat cable. Again, I like to bend these wires over, and sometimes they fit a little tightly, so you have to use a pair of pliers or something to smash them down flat. But by bending it over, it guarantees that the thin cable is firmly attached to the wire and can't come off. And this connection will then plug onto one of the two coil connections on the relay. And again, if you don't know which is which, simply look on the side. Now, crimping on yet another female spade connector onto the blue wire set, it holds the wires together and gives us the remaining connection that we need to energize the coil. This blue or common wire then, of course, will stay connected at all times. When power goes down the red and returns from the thermostat to the yellow, it will engage the compressor and the fan. And you can see here, looking on the side of the relay, the connections labeled 1 and 3 here have between them a little twisty coil section. This represents the coil that creates a magnetic field that pulls your contacts closed. And again, you see here it says the coil is 24 volts and that the contacts are rated 12 amps at 125 volts AC. So again, to trace out the power, our power comes down our common wire from the transformer, connects to the coil on the relay, and then goes down the blue wire into the house through the thermostat cable. This would be used to power one side of your thermostat. Your other wire, the yellow, then connects to the red in the thermostat cable and goes to R on your thermostat. This not only powers the thermostat, but then sends power back down the yellow wire, powering up the coil, closing the connections, connecting our 120 volt AC to our fan and our compressor. With all the wiring now completed, you have to find a place to stuff your relay in the box and make sure that nothing electrical can touch the case or anything else electrical. If necessary, wrap everything in tape. We're going to pull our thermostat wire through the hole that was previously used for the knob on the thermostat. And then we're going to close up our case. With the remote operation electrical components installed and ready to go, put the case back on. It's very helpful to simply start each screw and not snug it up very much, if at all. Just simply start each screw for every single hole in the case. And once every screw has been put in, then go back and tighten down every screw. By doing this, it allows you to move the case around and wiggle the unit to get everything back exactly where it should go. So now here where the thermostat cable has been brought through a hole, there's really not a proper connection to protect the wires from being rubbed through. So I'm going to put a few wraps of electrical tape around it, and then we're going to push it halfway back into that hole. And of course you could use a fastener here to attach the wire down against the unit so that it can't go anywhere. This video is shot slightly out of order, but the point is just the same. You're going to measure to the furthest position back that you'll be able to cut into your case. And then in this case, I'm going to take a drill bit and drill a hole and verify the exact placement of the cut by looking inside where the drill bit comes through. We're using a 4" by 8" to 5" uninsulated boot. So I'm going to lay this on top of the unit and lining it up with the marks and measurements that have been taken, and then I'll simply draw a line around the boot on the case. And then using an angle grinder, I'm going to slice the case open at this point. Fold the metal up, putting your fingers on the back, and make the bend as close as possible to match the flush back of the unit. Or should I say, to make it flush with the back of the unit. Then insert your boot to be sure that everything fits okay. In this case, we have a little styrofoam that is in the way that keeps the boot from sitting all the way against the back. So I simply take a razor knife and trim off any of the styrofoam that's in the way of the boot sliding in and snugly against the back. Now you notice it cut all the way through the foam into the outside part of the unit, but that's not going to be a problem. I turned on the fan and blew out any of the trash that might have fallen to the bottom. Now setting the boot in once again, we're going to take a look around the boot and inside of the boot to make sure that everything lines up well. Basically, we want to be certain that the airflow is unobstructed and can come straight out of the fan section into the boot without any obstruction. Now we'll use our foam. This doesn't have to be a foam gun like this. It can just be the cheap polyurethane foam that you get in the can, the great stuff. So we apply a layer of foam between the boot and the styrofoam in the back, and then we push that into place. And just to be sure that it doesn't move around and to make everything generally more secure, we're going to put a couple of self-tapping screws through the case and into the boot. Now we just apply the foam into every single crack and crevice all the way around the boot, filling in every gap and space we can. The more contact area we have, the more securely this will be held in place. This foam, if you've ever gotten into it, you know well that it's very much like a glue. It sticks to almost anything, and we're going to just really put this on heavy because we're going to be depending upon this stuff to act as a glue and a sealant to secure it in all directions mechanically, and of course to keep the air sealed in as well. It's even a good idea to look in the top and go ahead and add additional foam around the edges, because that'll just be more mechanical attachment points anywhere that you can put foam. And you see it's growing a little out of control in some places here, but that's okay. Depending on the type of foam you have, you need to return in 20 minutes to as long as maybe 3 hours once the foam has fully cured. And then you simply use a razor blade and you carefully trim out all the excess foam, anything that would be in the way of the face of the air conditioner fitting on, anything that would be in the way of the airflow on the inside. Simply cut that foam and then pull it loose and get everything cleaned up. And so now for the attachment of your return line, you have to really look things over. The way some of these really cheap units are made, there's not a lot of space to work with. Sometimes you can remove the front and sometimes you can't. And actually, you know, every unit really needs an air filter. and I actually like the way that this particular air filter is easy to put in and remove. So I decided that I'm going to keep the front of the unit intact. But the trick, of course, is making sure that nothing sticks into the case enough to interfere with the insertion of the filter. We will set our 12 by 12 by 8 boot onto the face of the unit and just kind of get an idea of how to fit it and how to center it to maximize the airflow. Now I just use a marker and mark out on the inside of the boot because I don't want it to slip down inside of the case any at all. Now you see we pretty well centered it as best we could from top to bottom to maximize the amount of airflow that's going to go directly through the middle of the coil, which is the highest airflow area directly in front of the fan. And we're going to have to avoid this material around the edge of the face. So we just do the best we can do with what we've got to work with. And in this case, it just happened to work out just about perfect. So here I'm using an angle grinder, and I'm going to cut off the little cross sections of plastic, and then we just slice through the rest of it. And once that's done, we just get everything in alignment. We get out the foam gun and we just apply liberal amounts of foam all the way around. And I'm even going to use the foam to fill in the grill to the sides. That way each and every crack on the face is completely sealed. And at this point, don't worry about it going everywhere. We can always clean it up later. I even apply foam around the inside so that it connects to the inside of the metal and reaches down and touches the foam that's sticking through from underneath. This just gives a more secure mechanical connection. As before, in 20 minutes to as much as 3 hours, once the foam has fully cured, we just simply come back and we trim off all the excess foam. We don't want to necessarily loosen it up from the face in any way, but we definitely want to remove anything that's going to obstruct the filter from being inserted, as well as anything that might be obstructing the flow of air. And here I had to trim off a little piece off of the cover because it was actually bumping into the supply boot. And that's pretty much it. We're ready to put the front cover back on. Pull our thermostat wire through the hole in the front of the unit. Attach and put the screws back in the face. And now time for a test run. Using a wire nut to connect the red and yellow wire together, the unit comes on as expected. And we have nice, cool air blowing out of our duct. Our job is done here. In fact, since the air is going, whoo, that's cold. Well, I hope you might have found this project interesting. Would this be worth it for somebody to do versus buying all these parts if you didn't have the tools to do this? Somewhat questionable, and certainly not as easy as just buying something off the shelf, but at least this way, when you put the duct on, you have insulated duct, so it's a little more efficient than the duct that comes with the other unit. And quite honestly, it's really a pretty quick way to get a very functional system for your tiny house, for your yurt, for your micro house, anything that you just need to get the job done and you're trying to pinch a few pennies. Oh, and whatever you do, don't forget to put the filter back in or on, or provide another means of air filtering, because you do not want to run your unit without an air filter.